Bismillahirrahmanirrahim. This is chapter 10, but we will be covering only composting because this is a very important part in wastewater treatment. Remember that we went to Slabiya. The engineer told us that the sludge, I'll just mention the process coming to Slabiya, aeration tank, where the biological happens inside, second clarifier. Some of the sludge settled at the second clarifier. Some of the sludge is being recycled back to the aeration tank. Remember what was the name of that? Retain activated sludge. And the remaining is wasted as waste activated sludge, and the clean water going to the remaining process, whether it is disinfection, filtration, and then later on ultrafiltration and reverse osmosis. There is no need for reverse osmosis and ultrafiltration because we need this for irrigation. So this process, this good water is good for irrigation, for plants, for grass, for trees, this water. Now, why we have to waste? Remember, we have to control F/M ratio. We have to make the bacteria under starvation. We have to not let them eat everything. We have to make, I remember we asked the engineer at that time, he told me that F/M is almost 0.1, and that is good. F/M, remember, we have too much microorganism and we have less food, which means that he is recycling activated sludge more. And the food coming is, of course, the food is coming is a lot. We are talking about 600,000 متر مكعب باليوم, okay, of water is coming in. That's huge amount. So the controlling F/M will force us to waste some activated sludge. What happens in this waste activated sludge? If you do a proper composting, if you do a proper treatment, and one of these treatments is composting, you'll have a good compost. You'll have تسوي سماد طبيعي, مو سماد صناعي, سماد طبيعي حق الأرض الصحراوية اللي ممكن باكر تصير جنة أو ممكن تكون أرض صالحة للزراعة. Okay, so let's look at this only this because this is part of the design that you're going to be designing for the wastewater treatment plant. The waste is produced and processed down to a suitable size. Remember that he was talking about tons. A lot of tons as being produced per day from Solebia. A lot of tons coming from here. A lot of tons of sludge is coming from here. What did they do with it right now? Nothing. It's piling up. If this volume is processed down to a suitable size, the volume will be reduced if you do proper composting. Sometimes we add water, sometimes we add air to have aerobic degradation of the waste. Sometimes the waste is mixed. Sometimes this waste, the sludge, is mixed to ensure even degradation. And I'll tell you why we have to mix it, why we have to mix it with something else. Because these microorganisms are used to degrade the organic matter of the waste and produce carbon dioxide and leaving behind a solid called compost or samad that can be applied to soil and make the soil fertile. So what is the objective of composting now? To reduce the mass of the waste to be managed. It's going to be a lot of tons. ممكن إذا كان 30 ton, it might be being reduced to 1 ton. And that is good reduction. Composting will do that for you. Also reduce pollution potential. Why you want to go and pile up the sludge like mountains in Chebd? Why? This will reduce pollution by doing composting. You're not having air pollution coming out of the sludge. You're not allowing groundwater pollution. You're not polluting the soil. You are treating the sludge to a proper compost. And of course, destroying pathogens, any pathogenic material inside, or any pathogenic microorganism inside the sludge will be destroyed because of composting. And we can produce a product that can be marketed. Of course, this can be sold or used by local community. Okay. Now, common application for composting. So, industrial and agricultural waste such as wood waste can be used, fish processing waste can be used, solid generated at a municipal wastewater treatment plant like the one we have in Slaybia. Again, it's not only wastewater that's coming out from domestic, also fish processing can be used. Wood waste can be used because wood is a very good carbon source. Source separated municipal solid waste can be used like trash going out, the food, such as also yard waste collected. Food waste collected can be used as a proper common application for composting. Okay. Most common type of composting, either we have windrow, and that is the easiest way. Put it in the land. Okay. Either in trapezoidal pile, which is to process the organic matter, left in the open air. And of course the organic matter needs to be mixed occasionally to spend time inside the pile. Or in vessels, داخل container أو داخل reactor to maintain the processed organic matter in a large container. Okay. So, of course, there's designs you have like windrow or vessels, the particle size specification for most common types, the type of waste used in windrows, mixed yard. Here you could have yard and food because you might have a lot of smell, so it's good to contain it inside the vessels. This is a mixing frequency is once per week, and here it's a reactor. You mix it hourly. Time to obtain compost, and that is a major thing, 2 to 4 months. But this one is much smaller. Right now they sell in Amazon a small composter for kitchens. You could add food. Of course, it's closed. Otherwise, you're going to have bad smell. Compost. You put your food, you put your paper, you put your everything left over from the kitchen, and you can have a big amount. After like few hours, this will be transferred to a nice, of course, nice small compost out of the composter. Okay, most common types that we have here is either the windrow or the vessel composting that comes from kitchen and yard waste. And as you can see that there's a reactor. They put the waste and it's closed. It's not open, it's closed. So everything is happening inside the reactor. Important consideration. Production of compost requires providing the right conditions for aerobic microbial growth, maintenance of temperature at 40 Celsius for several days and longer time. Okay. Rapid release of heat in the composting system can raise the temperature to 70 Celsius, which lead to kill all pathogens. And also the process should be controlled through the nutrients. Sometimes we add nitrogen content. We have to know what is the nitrogen source. If they need nitrogen, we'll give them nitrogen. And also pH, we have to control pH. We have to control the moisture. That's why we have to add water sometimes to make it moist, and controlling the air content. Important consideration in composting. The nutrient content is commonly expressed as carbon to nitrogen ratio. This is very important. When you need to make samad, when you need to make a compost for the soil, you need to make sure that the carbon to nitrogen ratio, C/N, is controlled. And this should be in a dry weight basis. The ratio should be in the range from 20 to 40 for materials entering the composting process. It has to be in the 20 to 40 range. When one waste is not compostable, it can be mixed with other one. Sometimes you have trash from food. When you check C/N, it's not from 20 to 40. So you have to mix it with something else. You have to sometimes mix it with other material to ensure proper nutrient content. C/N, it has to be from 20 to 40. This is the proper nutrient content. Of course, pH has to be controlled. Moisture content has to be controlled, and air porosity has to be controlled. Okay. This is a table in the book that shows if you have, like, for example, if you have poultry manure, that's from chicken, a nitrogen percentage dry mass 5 to 6.3%. A C/N for this poultry manure is 15. Okay, C/N. So there's no units for this. If you have oat straw, it's 1.1 nitrogen percentage in by dry mass and 48 C/N. We'll show you an example right now, and that is similar to the one we have. Let's see, sludge from waste activated sludge, okay, will be checked for carbon over nitrogen ratio. إذا كان الكربون over nitrogen ratio is not from 20 to 40, then we have to mix it with something else. These people, they have a lot of poultry manure. Hold on. Okay, and C over N is 15. 15 is not good. We need 20 to 40. So they add up with it oat straw. Okay, oat straw has a C over N 48. Of course, we have to account for nitrogen inside because C over N is also a variable that we have to look at. Let's look at this example. Poultry manure has a moisture content of 70%. We have the poultry manure has a moisture content of 70%, 6.3%. Remember, moisture content is very important. And then 6.3% nitrogen. Okay, this is on a dry mass basis. Should be checked on a dry mass basis, not in wet mass basis. The manure is to be composted with oat straw with a moisture content of 20%. The desired C over N, he went to 30, which is 20 to 40. That's fine. This is good. Using table 10.11 values for the nitrogen composition and C over N ratio for these two materials, determine how many kilogram of oat straw required per kilogram of manure to attain the desired C over N ratio. Come kilogram of oat straw I'm going to put per kilogram of manure of poultry manure in order to attain a C over N 30. Okay, so we'll do it like this. We're going to assume that we will have 1 kilogram of moist poultry manure dry mass. We're going to assume that. This is good that we have to assume it. And we're going to assume that X is equal kilogram of moist oat straw on a dry mass basis. Okay? This is always happening. You have to assume 1 kilogram and the rest X. Okay. Let's look at the first one, dry mass of nitrogen from poultry manure. And we assumed it. The poultry manure is 1 kilogram, so 1 kilogram times. What is the percentage of dry weight? This is 70%, but this is moisture. So 1 minus 0.7 to make it dry. Times, this is, remember, this is nitrogen. What was the nitrogen for nitrogen? Oh, it's given here. So it's not from, you can find it from the table, but it's given here 6.3%. So 6.3 over 100. That would give you 0.0189 kilogram of dry mass nitrogen inside the poultry manure. Let's look at the dry mass of carbon from the poultry manure. This is nitrogen and this is carbon. So it's 1 kilogram. Still, it's poultry manure, so it's 1 kilogram times 70%, 1 minus 0.7 to make it dry, times. Now, he need here carbon. Remember carbon. What we have here, we have nitrogen. So we'll do nitrogen times C over N in order to get the carbon. Remember, we have the 6.3% that is for poultry manure nitrogen. And let's look at C over N for poultry manure. It's 15. So you multiply this by 15 to get 0.2835 kilogram of dry mass carbon from poultry manure. Now, next, we'll do the dry mass nitrogen from oat straw. Nitrogen from oat straw. It's X kilogram because I'm assuming it is X for oat straw times. What is the percentage? Let's see here. It said the moisture content of oat straw is 20%. So 1 minus 0.2 times. And the nitrogen, he did not give us for oat straw, so I'll go take it from the table. And nitrogen is 1.1 and C over N is 48. So we'll go here and multiply it by 1.1%. And this would give you 0.0088 times X kilogram. And that is the dry mass nitrogen from an oat straw. This is a function of X, the variable X. Then we find dry mass carbon from oat straw. X kilogram times 1 minus 0.2. He told you the 20% moisture times nitrogen, which is 1.1%, times C over N, C over N. This cancel with this, you'll have carbon now. You will have carbon now. This would give you 0.4224 x kilogram. So now we need this C over N 30. So we're going to put the carbon up and we're going to put the nitrogen down. So you're going to put the carbon for the poultry manure, which is whatever he gave you here. This is the carbon. This one, you'll put it here. And we'll put the carbon for the oat straw, here 0.4224x, here this one. ونقسمها على النيتروجين. This one 0.0189 plus this one, this is nitrogen 0.0088x. خلاص, now we should solve for x. We're going to get at the end that we find that this x is 1.8 kilogram, and what we conclude that for every 1 kilogram of poultry manure, we assume that we're going to add 1.8 kilogram of oat straw. Okay, for every 1 kilogram poultry manure, we're going to add 1.8 kilogram of oat straw in order to have a C of an N of 30. Now we are fine. Now we're going to produce something that's make the land fertile, and inshallah everything would be good for creating the country, greenery and trees and everything else that inshallah that's going to be looking good. I mean, this is an example of poultry manure, and this is an example of oat straw. Thank you.